We just learned matrix operations. Now, for one video, we pretend we are back in high school solving linear equations by hand. Do not panic. The matrices will return. They always do, like unpaid notation debt. Here is the system we will solve. The goal is not to be clever. The goal is to eliminate variables in an organized way, because random algebra is just chaos with better handwriting. First, move the top equation to the bottom. The equation x plus y plus z equals 9 is more convenient because the coefficient of x is 1. We are not changing the problem. We are just changing the order. Very rebellious. Completely legal. Now use the first equation to eliminate x from the two equations below it. For the second equation, subtract 2 times the first equation. That turns 2x plus 3y plus 5z equals 36 into y plus 3z equals 18. For the third equation, again subtract 2 times the first equation. That turns 2x plus 7y plus 20z equals 123 into 5y plus 18z equals 105. Now x appears only in the first equation. That is elimination doing its one honest job. Next, use the second equation to eliminate y from the third equation. The second equation is y plus 3z equals 18. To remove 5y from the last equation, subtract 5 times the second equation. The last equation becomes 3z equals 15. Now the system is triangular, which means the hard part is over, and algebra briefly stops pretending to be mysterious. Now solve from the bottom upward. From 3z equals 15, we get z equals 5. Then y plus 3 times 5 equals 18, so y equals 3. Finally, x plus 3 plus 5 equals 9, so x equals 1. The solution is x equals 1, y equals 3, z equals 5. Somehow, civilization advances. Now we repeat the exact same method using augmented matrices. The augmented matrix stores the coefficients on the left and the constants on the right. Moving the top equation to the bottom is now just swapping rows. The elimination steps now become row operations. Subtract 2 times row 1 from row 2, and subtract 2 times row 1 from row 3. This gives zeros below the first pivot, just like eliminating x in the equations. Notice that the row operation touches the entire row, including the number after the vertical bar. The constant does not get diplomatic immunity. Now eliminate below the second pivot. Subtract 5 times row 2 from row 3. Now the augmented matrix is in triangular form. It represents the same triangular system we solved a moment ago. So again, z equals 5, y equals 3, and x equals 1. This example suggests the general moves we are allowed to use. The first operation is swapping 2 rows. The second is multiplying a row by a non-zero scalar. The third is adding a multiple of one row to another row. These are called elementary row operations, and they preserve the solution set. In plain English, they change the packaging, not the answer. Gaussian elimination is the systematic use of these row operations to make a system easier. Start with a system. Use row operations to eliminate variables. Aim for triangular or echelon form. Then solve from the bottom upward, or read the solution structure directly. The method is mechanical, which is good. Mathematics has enough opportunities for creative suffering already. Let us summarize before we make elimination look more official next time. First, we solved the system by ordinary equation elimination. Then we did exactly the same work with augmented matrices. The allowed moves are elementary row operations and they preserve the solution set. Next time, we will define Gaussian elimination more carefully and talk about echelon form. Because every useful method eventually demands terminology. Naturally.